Hi, in this video, we're going to take a look at how to calculate the present values of annuities and perpetuities with constant growth. So we still have constant discount rate, but instead of constant cash flows, we have a cash flow that's growing at a constant rate. Okay, so let's take a look at this example. If I have 3 years here, and my first payment will be at the end of year zero or at the beginning of year one, which is £1,000. But instead of having constant cash flow throughout the 3 years, this cash flow will grow constantly at 5%. So for the next year, I'm going to have 1,000 multiplied by 1.05. And for the third year, I'm going to have 1,000 multiplied by 1.05 squared. Okay, so how do we calculate the present value of this? We can still do it in the manual way, which is discounting the individual cash flows separately and then add them up together. So let's try this. So if I have 1,000, which is the first payment, divided by 1.1, just discounted once, and 1,000 times 1.05 divided by 1.1 to the power of 2, and then 1,000 multiplied by 1.05 to the power of 2, and then divided by 1.1 to the power of 3. Okay, I can always add these numbers together, and it should give me 2,604.18 pounds. Okay, so that's the present value. So can we generalize this and change the annuity formula and the perpetuity formula so we can use a shortcut? Yes, and if you can see here, it's still a summation of geometric series. It's just that the common ratio has changed from 1 over 1 plus r to the new number of 1 plus g over 1 plus r. Okay, so if you remember from our previous videos that the summation of geometric series is simply a 1, which is the first term, times 1 minus q to the power of n, and 1 minus q. Okay, so if we just plug in the numbers here, we should get the same result. But if we use C here, or the first cash flow, as the first term, so we can change the common ratio to 1 plus G to 1 plus R. Okay, so N is now how many years? So T here. Okay, and divided by 1 minus Q, which is now 1 minus 1 plus G over 1 plus R. Okay, so remember, this is when we treat the first payment, which is the payment at year 1, as the first term. So we still need to discount it back to year 0. So all of this will be multiplied by 1 over 1 plus r. Okay, so if we simplify this, so basically if you can open brackets and multiply this thing into the brackets, so it's going to stay on the denominator and on the numerator, and then you're basically simplifying the denominator a little bit. So it becomes C 1 minus 1 plus G over 1 plus R to the power of T, and then, 1 plus R minus 1 minus G here. Okay, so if we further simplify this, we simply have the annuity formula with growth, with constant growth, which is C over R minus G multiplied by 1 minus 1 plus G over 1 plus R to the power of T. Okay, so there you have it, the annuity formula for annuity with growth. Okay, so what about perpetuity here? So if T is sufficiently large or infinitely large, and with another assumption that R is greater than G here, then we'll always have this number here to be less than 1. So if T is sufficiently large, then this term goes to 0. So we're simply left with C over R minus G here. Okay, and remember the assumption of R is greater than G. So how do we comprehend this in an intuitive way? So the discount rate is always greater than the growth rate. So the growth does not catch up with the discount. So this number is going to, or the cash flows, no matter how they'll grow, they're never going to catch up with discounting. So they'll be smaller and smaller and smaller, so they'll converge to a single value. And that's why we can use the C over R minus G. So what if it's the another way around? So if we have G is greater than R, so the growth is so rapid that discount cannot catch up with the growth, then the cash flows is always going to increase. And the longer the time is, the bigger the cash flow is. So if we add them all up, there's not going to be a definitive number. So it does not converge, and this formula does not apply here if you have G is greater than R. So what happens if we do have G is greater than R? Then we're only going to use the manual way. Okay, we can still revert to the manual calculations, but don't worry about it. It's not going to happen very frequently because this sort of growth is very likely to be unsustainable. So it only happens for a few years and then the growth will diminish. So then you can apply the annuity formulas or the perpetuity formulas again. But for the first few years, when you have G is greater than R, you must do it in a manual way.